Welcome back, GCC Chem 130 students. We are still in Chapter 5. It's a long chapter, but we are way over halfway done. We're getting close to finishing this chapter, so stick with me. All right, so now we're going to basically talk about the motivations of the atoms. Why do they do what they do? Why do they bond? Why do they make bonds with other atoms to form compounds? Why do they make molecules? What is it that they're doing? Why do they gain and lose electrons? Well, again, the goal of the atom is to be like a noble gas, and it wants to have the same number of electrons as a noble gas, and end up with that S2p6 configuration, 2 plus 6 being 8 electrons, the octet rule. So let's talk about group 1A. The first column, group 1A. They all end with S1. They just have one little electron in their outer valence shell. So what do they want to do with that one electron? Well, they want to get rid of it, don't they? They want to get rid of it, and then they will be like their nearest noble gas. So if they lose that little S electron in the outer level, we go back to the next level, which has S2p6, which makes us happy. So they all want to lose an electron. So again, one negative electron is going to go away. This makes them have a +1 charge. Okay, when you lose negativity, you become more positive. So everything in the first column wants to be +1. So let's remember that. If you have your periodic table, write a +1 at the top of that column. Column 1 is +1. So group 2A, the second column, the beryllium, calcium, magnesium column. What do they want to do to be like a noble gas? How can they be happy and stable? Well, they have 2 electrons in their outer level, right? S2, it's the S2 column. So if they get rid of those 2 electrons, they'll move back 2 spaces and be like a noble gas. So they want to lose 2 electrons. So they lose 2 negative electrons that go away. So they lose 2 negatives. That makes them +2, +2 charge. So on your periodic table, write a little +2 at the top of column 2. So column 1 is +1, column 2 is +2, charged when we become an ion. So we can just generalize now. Metals, most of the atoms are metals. They're on the left side of the periodic table, left from that stair-steppy line. Metals tend to lose electrons. So they lose negativity, which makes them become positively charged ions, which we call cations. The plus is right in there, the T. The T is a positive plus. So cations are positive ions because of that T. That'll help you remember it. So group 1A becomes +1. Group 2A becomes +2. Remember, group 3 is the aluminum column. Group 3 is the boron aluminum column, and that becomes +3. Now, you can write these like the example. Magnesium can be shown as Mg+2 or Mg2+. Doesn't really matter to us, it's the same thing. If it's a +1, you don't even have to write the 1. For example, you can omit the 1 in K+1. You can just do K+. There's no number there, so it implies a 1. But if it's a 2 or a 3, you have to write the 2 and 3. So aluminum as an ion is +3. You can't just put plus, you have to put +3. Calcium as an ion is +2. Lithium as an ion is +1, which you can just write as a plus. B as an ion can be +3. Now let's look at our nonmetals. Let's go back to column 7A. Column 7. 7 is the fluorine, chlorine, bromine column. Now, they have S2p5 configurations. S2p5, so close to 6. What do they want to do? They want to be like a noble gas. They're S2P5. They want to be S2P6. So are they going to gain an electron or lose an electron to go from 5 to 6? Going to gain, right? They're going to gain an electron. So everything in column 7A wants to gain 1 electron. So they're going to gain a negative electron. So they have 1 more negative electron than they started with. So they have a -1 charge, like Cl minus. Again, you can put the 1, but you can omit it as well. Cl minus, there's no number there, so it's implied it's a 1. All right, what about group 6 next to that? The oxygen column. What do they want to do? They are S2P4. They want to be S2P6. So what is column 6A going to do? Again, they're S2P4. They want to be S2P6. So they are going to gain 2 or lose 2 electrons to go from 4 to 6. Gain, yeah, they're going to gain 2 electrons. So 2 more negatives than they started with. It's going to make them -2 charged. You have to write the 2. So they want to gain 2 electrons. Then they have 2 more electrons than they started with, so a -2 charge, like oxygen 2-. Good job. Good job. So we can now generalize with the nonmetals. The nonmetals are on the right side of the stair-steppy line, except for the noble gases, of course, which are already happy. The nonmetals, there's not very many of them, but they will gain electrons, becoming more negative than they started, and these are called anions. Anions. So group 7 becomes -1 charge, so write a little -7 above fluorine, -1. Group 6, oxygen's column, becomes -2. Write a little -2 up there on your table. And group 5, the nitrogen column, becomes -3. So write a little -3 up there. That's in general. All right, good job. So to summarize, metals like to lose electrons, becoming positively charged cations. Nonmetals, not the noble gases, the other nonmetals gain electrons and become negatively charged ions, anions. Well, I skipped a group, didn't I? I skipped the carbon column, column 4. I skipped it. That's because they don't just have one option. They're right in the middle. They can gain or lose 4 electrons, so they can be plus or -4 depending on what they're bonded with. Sometimes they only get halfway there, so sometimes they're plus or -2. It all depends on which element they bond with. So above column 4, I would write plus or -4 for their charge. And then what about group 8? They're already happy, so they don't gain or lose electrons. So they're 0. They're 0. So let's look at the charges all the way across the periodic table now. Column 1 is +1. Column 2 is +3. Column 2 is +2. Column 3 is +3. Column 4 is plus or -4. Then we're going to count down -3, -2, -1, and the last column is 0. Let's do it again. Starting with column 1. +1, +2, skip over here, +3. Carbon column is plus or -4. Now count down. -3, -2, -1, 0. Again, those are the charges for when you're an ion. What's your charge when you're an atom? This is a trick question. What's your charge when you're an atom? Well, atoms have equal protons and electrons, so they're all 0. Neutral. Atoms are neutral. So all the atoms are neutral. It's only when you've gained or lost electrons that you're an ion and you have a charge. So don't forget that. Atoms have a charge of 0. All right, what charge will be on these ions when they're an ion? Lithium, first column, plus 1. Magnesium, second column, plus 2. Sulfur, sixth column, minus 2. Bromine, seventh column, minus 1. Nitrogen, fifth column, minus 3. Aluminum, third column, plus 3. All right, this is very important. You've got to remember the charge for atoms when they're ions. Again, it depends on their column. Rewatch this section again. I think you should. Rewatch this again. All right, now I have a new vocabulary word for you, isoelectronic. Isoelectronic means same number of electrons. Iso means same, electron means electron, isoelectronic, same electrons. So when two ions or atoms have the same electron configuration, they're isoelectronic. So what atom is isoelectronic with Mg plus 2? Well, Mg plus 2 has 10 electrons. Who else has 10 electrons? Well, number 10, neon. Neon has 10 electrons. Yeah. So neon and Mg plus 2 have the same electron configuration. 1s2, 2s2, 2p6. Again, we got that s2p6. Happy, happy, happy. What atom is isoelectronic with p3 minus? So p3 minus means we gained 3 electrons, so we're at 18 electrons. Who else has 18 electrons? Number 18, right? Argon. Yeah, so argon and p3 minus are isoelectronic. They have the same electron configuration. 1s2, 2s2, 2p6, 3s2, 3p6. Again, we end s2p6. Happy, happy, happy. All right, here is an example exam problem. So I want you to write down the electron configuration for these ions and who they're isoelectronic with. Okay, so get your scratch paper, get your pencil or pen. Really, this is exactly what we're going to ask on an exam or a quiz. So get your periodic table, hit pause, fill in this table. So hit pause now, hit pause. All right, we're back. I'm just going to show you the answers because you were supposed to work on this yourself. So calcium 2 plus means we lost 2 electrons. So we went from 20 back to 18, so we're isoelectronic with argon. So we're the same configuration as argon, 1s2, 2s2, 2p6, 3s2, 3p6. Again, we're ending s2p6, happy, happy, happy. Oxygen 2 minus. 2 minus means we gained 2 electrons. We have 2 more than we started with. So oxygen went from 8 to 10 electrons like neon. 1s2, 2s2, 2p6, s2p6, happy, happy, happy. Cl minus 1 means we gained 1 electron that's negative. So we went from 17 to 18 electrons like argon again. So it's the same as argon, which is like calcium plus 2. They're the same. And then the last one, aluminum 3 plus. 3 plus means 3 electrons went away. So we went from 13 electrons back to 10, like neon. So we're like neon, just like oxygen 2 minus. So same configuration. And again, both aluminum 3 plus and O2 minus are like neon. They're isoelectronic with neon. Calcium 2 plus and Cl minus were the same, like argon, so they're isoelectronic with argon. All right, good job. Last problem, last slide in chapter 5. I want you to fill in the protons, electrons, and neutrons and mass number, the atomic mass number, for these 4 atoms or ions. Okay, remember what the top number is? I hope you remember. And you can get the protons from where? I hope you remember. So hit pause and fill in this table. It's the last thing we're doing. And what's more chemistry than protons, neutrons, and electrons? Very, very chemistry. So yes, pause and fill in this table, please. All right, we're back. SE. If you look for SE on your periodic table, it's number 34. 34 is protons, which never changes. So both of the SEs have 34 protons. Now, the SE without a charge is an atom. So it has the same protons and electrons, 34. Now the SE with the -2 charge gained 2 electrons. So it went from 34 to 36. Now neutrons is mass minus protons. So 78 minus 34 is your neutrons. And then 78 is the mass number. That is the mass number. All right, so there are the answers for SE. Similarly, aluminum. Aluminum is number 13. That is the protons, which never changes. So both of the aluminums have 13 protons. Now aluminum, the atom with no charge, also has 13 electrons. But aluminum 3 plus means 3 electrons went away. So 13 minus 3 is 10. 10 electrons for that ion. Now neutrons is mass minus protons, so 27 minus 13, which is 14, and that's the same for both of them. And the mass for both of them is 27. So there we filled in our table. That is finally the end of chapter 5. Thank you so much for sticking with me. It's a long chapter. If you need to watch certain parts of this again, work on the worksheet. Good luck, GCC. See you in chapter 6.